Hello, PreCalc. This is going to be the review for your practice test for your test on Tuesday. So, what we talked about for section 4.1, how to determine if something is a polynomial. Well, for any function, f of x equals, here's the definition of a function if we forgot. A sub n, x to the n, plus the next term, so it goes down a degree, plus the next term, x to the n minus 2, plus, it keeps going, plus the second to last term, x to the first power, plus a sub 0. So in order for it to be a function, or for it to be a polynomial, our exponent in our polynomial needs to be a positive whole number. So if the degree of our polynomial is a positive whole number, then it's a polynomial. So let's look at these first problems. What is the degree of this function here? Well, we can rewrite 1 over x squared as x to the negative second power. The degree of this polynomial is negative 2, so this is not a polynomial because the degree is not a positive whole number. For 4, let's rewrite this x squared plus 3x plus 4 equals 0, because you just add 4 to both sides. Well, is this of the form a function in terms of x? Well, no. This is only an equation. So technically, this problem is not written in function form, so we don't say it's a function, so it can't be a polynomial. Even though this is of degree 2, that's a positive whole number, so if this was equal to y, then that would be a polynomial. 5. We can rewrite a radical in terms of fractions. So this expression is the same thing as x plus 1 to the 1/2 power. Well, let's look at the degree. The degree of this function is 1/2. It's positive, but it's not a whole number. So this is not a polynomial. 6. We have our function. The degree is 0, because we could rewrite this expression as f of x equals 8 times x to the 0th power, because x to the 0 is 1. So this is a polynomial. 7. Let's look at the degree. The degree is 3/2. So again, we look back. Is this a positive whole number? Well, it's positive, but it's not a whole number, so this is not a polynomial. Last one. Let's look at the degree. The degree is 1, positive whole number, so yes, this is a polynomial. So let's look at this next section, talking about transformations. If we have a function, let's say any function, equals a number to the n plus c. The number out front, this right here, this a value will give your stretch or shrink. If a is a fraction, then it's going to be a stretch. Likewise, if a is a whole number, then this is going to be a shrink. If these two terms are confusing, stretch is another way of saying the graph is going to get fatter. Shrink is another way of saying the graph is going to get skinnier. Let's look at the next bit. Let's switch colors. So if we have x minus b to the n, this x minus b term right here is going to give your horizontal shift. And why is that? Well, the number that we're going to plug into x to make this 0 is going to move this graph either left or right. This number here is going to tell us our x-intercepts. N is our degree. The last bit that we have to worry about is this c value. For c, this gives us our vertical shift. So let's look at these problems in the next section, see if we can determine the horizontal shift, the vertical shift, and the end behavior of this graph. So, for the first problem, let's make that a little bigger. We have y equals 1/2 x minus 3 to the 5th power. So the first thing I'm going to do is look at the degree and determine the end behavior. The degree is 5, so that's an odd function. And we know the end behavior for an odd function is going to end up in the first and third quadrant. Next, we're going to look at the leading coefficient, 1/2. So that tells me I'm going to have a stretch. Now, why is that a stretch? Well, if there's a fraction in front of the polynomial, it takes a longer time to reach the end behavior. So we have a stretch of 1/2. The next thing we can look at is inside the parentheses. Inside the parentheses, we have our horizontal shift. So this is going to shift to the right 3. So I'm going to start at the origin, 1, 2, 3, place my dot. And then we're looking at, is there any number on the outside? Well, it's really plus 0. So there's no vertical shift in our graph. So now once we have all of this, we can graph this. We know it's a 5th degree function, so it's going to look like a x cubed. So we'll have our graph look somewhat like this. Let's try one more. Let's look at number 10 here. Well, let's first look at our degree. We don't have any parentheses, so we look at our degree. Our degree is, this is for a negative x to the 4th. So our degree is 4. That tells me this is an even function, so it's either going to end, it's going to be concave up, or it's going to be concave down. How do we tell? We look at the leading coefficient, which is -1. So that means this is going to open downwards, or be concave down. So the next step, do we have any horizontal shifts? Well, we just have x to the 4th there, which is another way of writing x minus 0 to the 4th power. So our x doesn't shift any. Well, what about our y value? Well, we have a number on the outside, -1, so we move down -1. There's our point. We know it opens down, so we draw our graph. All right, next up, we're looking to find the x and y intercepts and a bunch of other information for this function. F of x equals x plus 1 quantity squared times x minus 3 to the third power times x plus 4 to the fourth power times x minus 2. These problems are super nice because it gives you the answer right in the polynomial because it's already factored for you. If it wasn't factored, we would have to do some work. But for right now, it is, so our life's easy. So all we look at is each of these terms and see what makes it 0. So, the first one, we have x plus 1 quantity squared. What makes that 0? Well, x is going to have to be negative 1. The exponent tells you how many times that occurs. So in this case, it happens twice. Next up, x minus 3 to the third power. So x, in order for that to be 0, has to be 3. That happens 3 times. Next up, x plus 4 to the fourth. The 0 is negative 4. That happens 4 times. The last bit, x minus 2, that happens once. What makes that 0? 2. The y-intercepts. Plug in 0 for x and simplify. So you have 1 squared times negative 3 to the third power times 4 to the fourth power times negative 2. This is 1, negative 27. 4 to the fourth is 256 times negative 2. That gives us 13,824. So my y-intercept, we're writing that as a point. The y-intercept is going to be located at 0, 13,824, which is a very large number. Kind of hard to graph. So let's keep going. If we look at the next question for this problem, we're looking at which points does this graph touch or cross the x-intercept? And how do you know? If it's an even number of zeros, which is another way of saying the multiplicity, if the multiplicity is an even number of zeros, that's going to give you a bounce. If the multiplicity is odd, then it passes through. So in our case, the zeros in which this bounces at, the bounces are going to happen at, well, negative 1 happens twice, and negative 4 happens 4 times. Where it's going to pass through, well, 3 happens an odd number of times, and 2 happens an odd number of times. So the next bit, which we kind of figure out intuitively from the graph, is find the behavior near each x-intercept. So we make a number line, and we put down our zeros. This should be negative. So the furthest one is negative 4. Then we go negative 1. Then we go to 2. Then we go to 3. Likewise, we can look at this as a graph. So let me zoom out just a little bit and draw you a graph. So we know from examination of our polynomial that this function is of degree 10. If it's of degree 10, then we know that the end behavior is going to look something like a x squared graph. So now we're going to plot we're going to put our zeros in. We have -4, -1, 2, and 3. And based on what we found in part C, we can look at starting from -4. Our graph is going towards -4, towards. It gets to -4, and what did we say? It bounces. So it's going to touch the x-intercept and go back the same way. Likewise, it's going to go up. It's got to come back down because we had to get towards -1. So what happens when we get to -1? Our graph comes down. It touches at -1. We said it bounced, so it goes back up. And it goes way up because our y-intercept was 13,824. So let's just approximate that. Eventually, our function is going to come back down and get at 2. What did we say happens at 2? Oh, passes through. And it's going to turn. And what did we say happens at 3? Passes through, which then goes right towards our end behavior, pointed up in both ways. So let's look at that as a sign chart. Sign chart is just saying what happens at the y values. So if I'm going along the x-axis, let's look at our graph. What values of y do I have going up till -4? Well, it's above the x-axis, so that means your numbers are positive. Between -4 and -1, my values of y are still above the x-axis, so that means my numbers are positive. Any number I plug into this function is going to give me, between -4 and -1, will give me a positive value. Then between -1 and -2, graphically, I'm still above my x-axis. So the values that I'm going to get out are still positive. Now, between 2 and 3, I'm below the x-axis, so my y values are going to be negative. And then past 3, my y values are going to be positive. Let's look at one more example of this type of problem. All right, let's take a look at number 12. We're going to try to find the x-intercepts, the y-intercepts, what the graph looks like, and then we're going to graph it. So let's take a look first at our function. We have x squared times x minus 3. So what makes this first term 0? Well, if we plug in 0, then this will all be 0. That happens 2 times. Our next quantity, x minus 3, well, what makes that 0? If we plugged in 3, that would make this quantity 0. So our 2 zeros are 0, and that happens twice, and 3, which happens once. How do we find our y value? Plug in 0 for x. So we have 0 times 0 minus 3, which is 0. So our y-intercept is at 0, 0. So it's going to be at the origin. Likewise, we can look at the degree of this. There's 2 x's here, there's 1 x here. So this is going to be a degree 3 function. Next up, does the graph touch or cross at each x-intercept? Well, if we look at our zeros, we have 0 happen twice. So we're going to have a bounce at x equals 2. Sorry, x equals 0. We're going to have a bounce at x equals 0. And we're going to pass through at x equals 3. Same thing we did before. I'm going to create a sign chart, but this time I'm only going to have 2 numbers. I'm going to have 0 and I'm going to have 3. And likewise, I'm going to draw the graph that represents this sign chart. But instead of, the sign chart's just one dimension, our graph's going to be two-dimensional. If we know it's degree 3, we know that the end behavior is going to be in the first and the third quadrant. And we know our zeros are x equals 0 and x equals 3. So we're going to start all the way down here in the third quadrant, and our graph's going to look something like this. Let's got to start from negative infinity and come up towards the origin. So our graph's going to be coming up towards the origin. And what happens at 0? Well, it's going to come up, get close, 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 touch, and then turn back around. Why? Because our graph bounces. It's going to head the other way. At a certain point, it's going to turn. We have to get back to 3. At 3, we know that a graph passes through, so it heads up towards positive infinity. So let's look at that in terms of a sign chart compared to our graph. All our y values all the way before 0, they're negative. They're below the x-axis. So going up, going up, going up, still negative values. I hit 0, but I don't go above the x-axis, so I'm still below, so that I'm still negative. The next point I get to is 3. Once I pass 3, my values will be positive. So there's my sign chart, and there's my graph. The sign chart tells me all the y values between my x-intercepts. So negative to 0, still negative till 3, positive after 3. Last two pieces of review. You should be experts at these by now. First two problems, 13 and 14, deal with long division. We already have the division problem set up. We want to see what x cubed plus 3x squared minus x plus 3 divided by x plus 1. So what do we have to multiply x by to get x cubed? Well, we multiply it by x squared. Put that over the x squared term and multiply. X squared times x, x cubed. X squared times 1 is x squared. And we're going to subtract both of these, which is the same thing as adding the opposite, all of those terms. By design, the x cubes cancel. 3x squared minus x squared gives me 2x squared. Bring down the rest of the terms. X times what number gives me 2x squared? 2x. Write that up there. 2x times x, 2x squared. 2x times 1, positive 2x. We're subtracting, which is adding the opposite term. Our 2x squareds cancel out. Negative x minus 2x is negative 3x plus 3. Last bit. What times x gives me negative 3x? Negative 3. So negative 3 times x is negative 3x. Negative 3 times 1 is negative 3. And we're subtracting, which means we distribute the negative sign, so we add the opposite sign. Those cancel. My remainder is 0. So our answer to this division problem is x squared plus 2x minus 3 and 0 remainder, which means, for later on, that x plus 1 is a factor. Last up, x squared minus 1 divides x to the 5th plus 3x squared minus 10. So just for our sake, I'm going to rewrite this problem so I have all of the placeholders in place. So I have x squared minus 1 divided by x to the 5th. Well, we have 0x to the 4th and 0x cubed plus 3x squared. What are we missing? One more. 0x minus 10. So a little more written out, but you see that we have placeholders for x to the fourth, x to the third, and x. So what do we do now? What number multiplied by x squared gives me x to the fifth? Well, x cubed. Multiply through. X to the fifth, negative 1 times x cubed is negative x cubed. We're subtracting, which means we're adding the opposite sign. X to the negative fifths cancel. We have x cubed, bring down the rest, 3x squared plus 0x minus 10. Next up, what do you multiply x squared by to get x cubed? Well, x plus x. Multiply through. X times x squared, x cubed. X times negative 1, negative x. We're subtracting, which means we're adding the opposite sign. Our x cubes cancel out by design. We're left with 3x squared plus x minus 10. Last part. What do we multiply x squared by to get 3x squared? 3. 3 times x squared, 3x squared. 3 times negative 1, negative 3. Subtract, which means we're adding the opposite signs. 3x squareds cancel, x comes down, negative 10 plus 3 is negative 7. So our answer to this division problem is x cubed plus x plus 3 plus our remainder, x minus 7 all over x squared minus 1. The last part that we're going to talk about is synthetic division. This only works if we have a polynomial divided by a binomial with degree 1. We have that, so what do? We draw our little line, our little upside down box. We take the opposite value here. What makes this 0? Negative 1. Now we write out our coefficients. We have 1x to the fifth. We have 0x to the fourth, 0x cubed, 0x squared, 0x, and 1. We bring down the first term. So this just comes for the ride. 1. Negative 1 times 1 is negative 1. Add. 0 plus negative 1 is negative 1. Negative 1 times negative 1. 1. Add. 0 plus 1 is 1. Negative 1 times 1. Negative 1. Bring it down. Negative 1 times negative 1 is 1. So we put that up there. 1 times add. 1. Negative 1 times 1 is negative 1. 1 plus negative 1 is 0. These are our leading coefficients for our new polynomial that's going to be of degree 4, because we're reducing x to the fifth down 1. So we're going to have x to the fourth plus negative x to the third plus x squared plus negative x plus 1 with 0 remainder. And if you feel comfortable writing, instead of writing all the addition signs, you can just say x to the fourth minus x cubed plus x squared minus x plus 1. Simple. Let's look at the second problem. Using synthetic division. So we write 3, which is the opposite sign out here, and we're going to write our coefficients. So we have 3, 2, negative 1, 1. Bring down the first term. 3 times 3 is 9. Add. 2 plus 9 is 11. 3 times 11, 33. Negative 1 plus 33 is 32. 3 times 32. Well, 3 times 3 is 9. 3 times 2 is 6. So that's 96. 1 plus 96 is 97. That's our remainder. So our x cubed term is going down by 1. So that means we're going to have a result of x squared. So 3x squared plus 11x plus 32 plus our remainder, 97 over what we were dividing by, x minus 3. Hopefully these notes were helpful, and I'll provide more for you guys as we go through Chapter 4. Have a good weekend.